Hello everyone. So I hope you are fine and in good health. So let's solve this question from partial differential equation. So we will solve this question with the help of direct integration. This is one of the important method to solve any partial differential equation. So what we do in this type of question, we do keep doing partial integration until we get z. Okay, so we repeatedly do partial integration one after another. Okay, until we get z. So before that, you can think that there was some z for which first we found del z by del y, then we again differentiated it partially with respect to x to get this, and then the result was again differentiated partially with respect to x to get this del cube z by del x square del y. Now order is not important here because they are continuous. You might do del by del x, del z by del x at first place, and then differentiate with respect to y partially, then differentiate with respect to x. But you have to keep in mind that you have to differentiate with respect to x partially twice and with respect to y one time. That timing is important, not the order, because they are continuous. So we started from z and partially differentiated 3 times. It's just like your gift pack which you make. Suppose this is your gift and you wrap up this with different colorful plastics or papers. So this wrapping you can think of partial derivative. So now if someone wants to reveal the gift, what is inside this gift, then what he will do, he will unveil this wraps one by one, but he will have to do it from outside. So if you can imagine that wrapping the gift is differentiation, then opposite of differentiation is integration. So unwrapping the gift can be thought of as integration. So we are going to do the same thing. We are going to unwrap this. That means undo the derivatives. How can we do that? We start integrating one by one. So first we'll integrate with respect to x. So this will be removed. Then again we'll integrate with respect to x partially. This will be removed, and finally we'll integrate with respect to y. So this will be removed, and finally we will get this z. I hope you understood this concept. Now coming to the problem. So let's take this as equation number 1. And what I told, just unwrap, just integrate partially. Okay. So integrate equation number 1 partially with respect to x. Okay, so what you will get now, because I have integrated with respect to x, so 1 del by del x I can remove. So I will get 1 del by del x. If removed, I will get del 2z by this 1x will go, so I will get del x del y equals to, this is nothing, I have integrated both sides. So integration of cos is simply sine 2x plus 3y, and if you go inside, you will again do the derivative of argument and divide by that. But be careful, because you are doing partial integration. So this 3y will be treated as constant. You will just make derivative of 2x, which is 2, and divide by just 2. Okay. Now there will be a constant of integration also. So because we have integrated partially with respect to x, taking y as constant, so this is important. Because I have taken y as constant, so I will take my integration constant also to be form of y only. So let's name this as f1y. Now this was just the first step, so you can name this as equation number 2. I will repeatedly do this until I get z. So I have not got z, so I will repeat. So now integrate. Look at this cover. I have removed this cover. Now this cover I have to remove. That means I have to integrate equation number 1 was here. Now it will be 2 partially with respect to x, taking y as constant. Okay, so if you do so, 1 del by del x will again remove, so you will be left with del z by this del x removed, so del y. Okay, now this got removed, so you are left with del z by del y. You have just integrated both sides, so integration of sine is nothing but minus cos 2x plus 3y. Now because you are doing with respect to x, so this y will be treated as constant, so again you have to divide by 1 2, because derivative of 2x is 2. 1 2 was already there, so 2 into 2 will get 4. Now here, because this is constant, so what you do, suppose you have some equation, let's say that y equals to 2, okay, plus x square. Okay, so if you integrate y with respect to x, so integrate individually 2 dx plus integral x square dx. So integration of 2 is nothing but 2x, because 2 can be treated as 2 into x power 0, and integration of x power 0 is x power 0 plus 1 divided by 0 plus 1, and here you will get x cube by 3 plus a constant c. So same manner, this is constant, so this can be treated as multiplied by x power 0, so 1x will simply multiply f1y. Another constant will come for this integration, let's name that as f2y. Of course that constant will be a function of y, because we have treated y as constant. Now a step ahead, let's name this as equation number 3. Now integrate equation number 3 partially with respect to, now wait, here you see del by del y. Now because you see del by del y, you have to do partially with respect to y, taking x as constant. So if you take x as constant, here this will be removed on integration, so you will get z equals to integration of cos, again simple sign, so minus sine 2x plus 3y divided by 4 was already there. Now this time you have to treat x as constant, so you have to divide by derivative of 3y, that is 3. 1 4 was already there, so 4 3s are 12. Okay, now here you come, x to be treated as constant, so x as it is, you have to integrate this, so integral f1y, okay, with respect to y, so dy, plus this again you have to integrate, so integral f2y dy. Now this, for this integration also you will get a constant, that constant will obviously be in the form of x, so let's name that as g1x. Okay, Now what we do obviously is, because we don't know what is f1y and f2y, so we this integration, whatever it will come as a function of y only. Same is true for this integration only. So we write our final solution something like this: minus sine 2x plus 3y divided by 12 plus x times, let me name this as h1y, plus let's name this as h2y plus g1x. This is my final answer. This notation can vary from student to student or teacher to teacher, but this portion will remain the same. That doesn't matter, this portion vary, this x will also remain the same. Notations may vary, but the idea was very important, that wrapping and unwrapping concept is analogous to differentiation and integration. Wrapping is differentiation, unwrapping is integration. Okay, so we just integrated it thrice. First 2 times with respect to x, because we have to remove this cover, and finally with respect to y, because we have to remove this cover. When integrating with respect to x, y was taken as constant, and when integrating with respect to y partially, x was treated as constant, and so was the constant of integration also. While integrating with respect to x, y was constant, so constant of integration was also in form of y. While integrating partially with respect to y, x was constant, so constant of integration was also in terms of x. And finally, because we don't like this notation, so we just tried, because we knew that this integration will anyway come out to be a function of y only, so we wrote it like this. So this is going to be your final answer to be reported. I hope you understood it and can solve same questions like this. Thanks and have a very nice day.